So now we'll be solving question number 14 from exercise 2 of chapter Laws of Motion, Facebook 1. Let's read the question. So an insect crawls up hemispherical surface very slowly, meaning driving force and static friction force is as shown in the figure. This is the figure. The coefficient of friction between the insect and the surface is given as 1/3. If the line joining the center of the hemispherical surface to the insect makes an angle alpha, meaning this is the angle alpha with the vertical, then the maximum possible value of alpha is given by. So we are talking about the maximum possible value of alpha for which insect is not falling. Meaning we are again going for the critical condition. Under the critical condition, what we do? We make friction as Fk and acceleration as 0. This is the critical condition. So let me make the FBD for this question. So I'll make the tilted FBD here. So one of the axes I'll be keeping along the radius and one of the axes I'll be keeping along the tangent at the maximum value. So at maximum value, I'm making the FBD. Let's say we're going for the value when the alpha is maximum. So this is the alpha. So mg is acting downward. As a habit, once we apply the driving force, we take the components of it. So we'll get mg cos alpha here and mg sin alpha in this direction. Now this mg cos alpha will be opposed by the normal reaction and this mg sin alpha will be opposed by the friction. So actually the friction is moving it up. This is the process of moving. Now under the critical condition, which is the maximum possible value, this friction will become the Fk and the acceleration will be 0. Any critical condition with friction, this is how you do it. So by balancing along this line, I'll get the normal reaction as mg cos alpha. That's the normal reaction. Once I get the normal reaction, I got the Fk as well. Fk is mu times of n, which makes as mu mg cos alpha. Now under the critical condition, Fk should be equals to downward force, which is trying to pull the insect down. That is mg sin alpha. So Fk is equals to mg sin alpha, and that makes mu mg cos alpha, which is Fk, is equals to mg sin alpha. Mg and mg cancelled out. Tan alpha becomes mu. And the value of mu is given as 1/3. As you can see, if I put it 1/3. Now, if you look at the option, there is no tan alpha. But the tan alpha can be written as 1 upon cot alpha. Tan theta is 1 by cot theta. And that makes cot alpha as 3. As you can see, first option is the right option in this case. So again, as you can see here, critical condition, we use these conditions. So whenever something with friction is there and they are talking about the critical condition, movement, non-movement, maximum, minimum, or anything, you put friction as Fk and acceleration as 0. And this particular case, we went for tilted FBD because that way the acceleration is a little easy and we get little easier equations. Thank you.